Okay, so let's start parallel lines and planes. Let's see. Let's just do name two parallel planes. Let's do number one. Oh, this is the wrong one. So the only ones here are the front and the back. And part of this is just a reminder of how to write planes. Like you can write the word plane and then 3 points. So like A, E, B. And then the back plane like C, F, D. You could name it other ways too. B, B, E, A, but you can't name it with 2 points. Oh. You can't name it with 2 points. And there was sometimes a plane will have a low capital letter like plane P or something. These didn't have that, so you had to use 3 points to name it. Let's look at skew. Name 2 segments that are skewed to AB. Okay, here's AB. So skew, definition, not on the same plane and not going to intersect. Let's see. So one's, I should have put this in blue. So let me draw in red. Here's what you could not put. You could not put any of those in red. Like BD is on the bottom plane, so that doesn't work. CD is on the bottom plane. AC is on the bottom plane. None of those work. E, B, and EA are on the front plane, so those don't work either. The other 3 segments work, so I'll put it in green. You could have put EF or CF or FD. Those are the only 3 options. Oh, and I said name 2 of those, so 2 of those 3. So it's EF or CF or DF. That's for 2. All right, and then on 3, name the intersection of the planes. Actually, this is a good question. Planes intersecting a line. That was one of the, actually that was unit 1 postulate. So like the floor and the wall intersect on a line. Same here. What is it? So it's AEB, the front plane, and CDB, the bottom plane. And so they intersect right here. So it's the line AB. All right, anything to add? Any questions on that first section? Now 4, I almost put this on the test. I thought it was a really good problem. This was some type of released question, like OST, released question. It's a good one. Part of it that I liked is, have we talked about parallelograms yet? No. But it helps you think, I mean, we can actually show a property of parallelograms even though we haven't done it yet. It's just everything we've done this unit. So first of all, you have to know what you're trying to show. Place statements and reasons to complete the proof that opposite angles of a parallelogram are congruent. So you first had to see that that was the parallelogram. And the opposite angles are 1 and 3. All right, they didn't say not alternate interior. That's different. Just opposite angles in the quadrilateral. So it's 1 and 3. So that's going to go here. I mean, remember, if that's what you're trying to prove, that's going to be the last statement there. So what's given is parallel lines, and then we need a way to show that 1 and 3 are congruent, and we do stuff. I mean, they didn't put 2 there randomly. They put it there for a reason, and it's all the stuff that we've been doing. So in steps 2 and 3 can be interchanged. Okay, the ordering here doesn't matter. I'll just start with this. 1 and 2 are going to be congruent. 1 and 2 are congruent. So both sets of lines are parallel, so M and N and K and L. Therefore, these are alternate interior, and so they're congruent. Now, it's alternate interior angles theorem. They just said alternate interior angles are congruent. That's actually pretty weak. They should have said either alternate interior angles theorem or because lines are parallel, alternate interior angles are congruent. but of these, the best option is the second one. Alternate interior angles are congruent. And then in a similar way, 2 and 3, we can relate those. They're along transversal M, but they are also congruent. 2 congruent to 3. Because they are corresponding. And so same reason as before, they really should say corresponding angles postulated. And sometimes they do. In some of these questions I've seen. But here they just said corresponding angles are congruent. There, so really, out of the options, of course, you really should have said that, but I'll put what they wrote down here. Okay, and finally, well, we knew it was going to be 1 congruent to 3, and we can look at our reasons. 1 is congruent to 2, 2 is congruent to 3, so 1 is congruent to 3. Transitive. It was the only property listed. There's some others that they did. I think they could have done better by giving you more options, like substitution, but. That's it. So, not really too bad once you start to piece it together what they're asking for. Okay, that was a good one. Any questions on 4? Let's do one number 5. First of all, on 5, when I say determine it algebraically, I didn't say graphically. So this means like, I'll put by hand. It means like show your work, like find the slopes. Because you could do it graphically. You could look at the graphs of each line. Plot the points, look at the line. All right, but what they're saying, I'm going to, by hand, find the slope of each of those lines. First thing I got to do is find AB and make sure I match up the points. Yeah, I didn't give them to you in order, so there's AB. I know what I was going to say in the practice. Okay, on this question, the slope formula is this, right? Y2 minus Y1. I saw a lot of us either mixing up the points, like doing B and D instead of B and A. And then a lot of us did this, like you did the formula as like 5 minus 6. Okay, and that's a Y minus X. Okay, you've got to get the Y terms together and then over the X terms. So I saw a decent amount of that. So really, this is one we need to make sure to work on. So this is, I'll just call this x1, y1, right? It's an xy point. This is x2, y2. So it's not 5 minus 6. You could do like 5 minus a negative 11. As written though, I called this y2. So it's really negative 11 minus 5. And then negative 2 minus 6. So that is negative 16 over negative 8, which is positive 2. And be very careful with these. A simple sign difference will cause the whole problem to be off. So then let's go to F and D. So x1 to y1, x2, y2. So it's going to be 8 minus a negative 10, which is plus 10, and 2 minus a negative 7, which is plus 7. It becomes 18 over 9, which is 2, and they are exactly the same, so it's parallel. Get careful on some of these. If you get something, like the next one should be negative 15 over 3, which is negative 5, and then 3 over 15, which is 1/5. Is that right? Yeah. So those would be perpendicular. If both of them were positive or both were negative, it's neither. Let's see if I say anything else. Yeah, negative 5 and 1/5. Okay. So first page, anything else we can go over? Any questions? Okay, let's keep moving. page 2. So let's do maybe a couple of 8, 9, 10, 11, and then what I'll start with number 7. If you want me to do 6, if you want me to do other line, I will. So let's do 7. This one you need to find x and y. I think we talked about this on Friday, like systems of equations with x and y. You're not going to have enough to solve those. So you just want to create one equation with one variable in it, not x and y. So I'm just going to compare the x ones. Since there's arrows, both sets of lines are parallel, I can move this one up to a corresponding position. That's a minus. And there's different ways you can move these around, but you should know that these two are going to be supplementary. What is that? Plus 7x. Okay, they're linear pairs, so you should add them to get 180. I'll do it. Combine like terms, 10x. Here, negative 160. And then you can add and divide, and you're going to get 34. That's all right. Yeah. Okay, and then, so one thing we missed on that quiz a little bit was, if you don't just use 34 as this angle, you got to plug it in first. Plug in 34, get a result, and then set up a new equation. So what do we got? 210, is that 238 minus 143, I think. So 95, does that sound right? It is, thank you. So then this whole angle, once I just plugged it in. Once I plug it in, I get 95 here. And so then I should do that plus this. 15 plus 5 equals 180. Okay, so if they were in corresponding or alternate interior, alternate exterior, or vertical, then you would set them equal. Linear pair and same side interior, supplementary. So let's just jump in. So you get 14. Yeah, definitely put one of those on the test. Can we do some lines? Any questions on these? Okay, let's do a couple of these, and then if you want me to do some more on page 2, I can. Anybody care which ones I pick here? Any of you want me to do? Yeah. 8? Sure. So one line parallel to line M, and it goes through this point. Do you want me to do slope intercept? Or point slope intercept? Now let's just put them all in slope intercept form at the end. So we want a line that's parallel. So we first need the slope of line M. We go over here. You can do one of two things. They give you points, and you can do slope formula, like we just did on number 5. How about on this? So I could do negative 2 minus negative 1 over 0 minus negative 4. Or you could do rise over run. So I could do rise of negative down negative 1 over 4. And that would be the slope. If I did it here, negative 2, 4, this would still be negative 1 over 4. So that's my slope, negative 1/4. And then if you're doing this one, you plug in your x of 2 and my y of negative 9. And then I solve for b. So this would be negative 2/4. 2 times a fourth, 2/4. And I'll multiply the 4 by 2. So then that's negative 1/2. So let's change it to negative 0.5. You can leave it as 1/2 if you want. And then I add 0.5 to both sides, so it should be negative 8.5 for b. And for all these equation ones, make sure you write the final equation. Slope negative 1/4, and then x minus e. Oh, and I put 17 halves. That's the fraction version on my key. Good with that one? Hey, you know what? I forgot to point out something. I'm sorry. I kind of jumped to it too quickly. This was our slope that was the slope of m. And then I should have said, hey, a parallel slope is the same slope. If it had said perpendicular, I would have chosen 4 right here, the flipped version, and made it positive instead. So I kind of jumped to that too quickly. Yes, parallel line, same slope. So like down here, on 10, once you get your slope, you flip it. Let's, I mean, all of 9, 10, 11 are pretty good. They're just different types of these. How would you do 1 of 10 or 11? Maybe 10, since it's perpendicular. Let's do that one. I'll do point slope for this one. So I'm going to go through 5, 3. 5 is my x1 and 3 is my y1. And so it's going to be y minus 3 something x minus 5. And I want perpendicular to this line. So I could have done this first if I wanted. I just need to solve for y. So solving that for y, subtract 4x, and then divide everything by 5. I don't need to do much more work. That's the slope right there. All right, I can cancel these if I want, but negative 4/5. So then the slope over here that I wanted perpendicular, positive 5/4. If it said parallel, you would have used the same slope. Okay, so I chose point slope. I mean, it's similar work if you've done slope intercept, but in this one, you have to distribute. So 5/4 times x is 5/4 x minus 5/4 times 5. Let's do decimal. It's going to be 25/4. 25 over 4, which is 6.25. Okay, so fraction or decimal either way. And then I'm going to add 3 to finish up. So minus 3.2. I probably put my answer in fraction form. What is this? 10. Yeah, 13 over 4 would be 3 1/4, or 3.25. Either way. How about just to make sure we're clear? I just want to start 9. On 9, you would first need to do the slope formula. y2 minus y1 over x2 minus x1. You see how this has come up several times now, so please make sure we know that slope formula. I should mention that too. There's hardly any formulas that are on the formula sheet, so you got to know equation of a line, you got to know slope formula, midpoint. I think that's some of the ones we need to see now. So you get negative 16 over 4, and you get negative 4, and then you use one of these points in this slope. Okay, what else do you want me to do on page 2? I can answer any questions, or we can move on. Anything else from page 2? Alright, let's flip it over to page 3, that's fine. There are a couple on here I specifically put on I do want to do, so let's go to page 3. 12 and 15 are ones I'm definitely looking at. So let's do 12. This is one where, again, you got to know slope formula. This is the type where you have 2 lines, and you have 2 points that are on those lines. The lines are going to be perpendicular, and they'll should find the value of a missing variable. It's the x coordinate here. So you get the slope of each line. So the first one is y2 minus y1 over x2 minus x1. Negative 1 minus 8 over 2 minus 4.
So that's negative 9 over negative 2, which will be positive 9 halves.
Then let's do this one. y2 minus y1. 5 minus 2 over negative 4 minus x. And so you get 3 here, and then this is just negative 4 minus x. You cannot simplify that. Alright, so all I'm going to do is, these are the slopes of the two lines. I know that they're perpendicular, so what I can do is I can flip this one and make it negative, and then it will be equal to that one. 3 over negative 4 minus x. If it said parallel, you just would have set them equal. But perpendicular, I'm going to flip this one, change the sign, and set them equal. Probably only one good way to solve this one, that's cross multiplying. Jump around here. So 3 times 9 is 27. And then I like to write this out because lots of times students forget to distribute the 2. Negative 2. So it's really negative 2 times negative 4 and times negative x. Not just times negative 4. So we have positive 8 and positive 2x. Subtract 8, you get 19, and divide by 2. And nope, 9.5. Okay, so I think I probably wrote mine as 19 halves, yeah, which is 9.5. So if x would have been 9.5, it would have made this one over here negative 2 9 is an opposite reciprocal. Okay, good. Questions on 12? Let's do 1 or 2 of 13. Given the following, which lines are parallel? And state the theorem. So if you remember, determine which lines are parallel. If you're showing lines are parallel, if that's a statement in your proof or something, the reason must say converse of. Right, converse is the one that just goes backwards. I'm thinking let's do B. I'll skip A. Let's do B. 1 and 2. 1 and 2 right there are supplementary. They sum to 180. You should first identify 1 and 2 while they're same side interior. Do we want same side interior to be supplementary? Yeah. Mm-hmm. So this one is good. Otherwise, you'd write no conclusion. This one's good. So which lines are parallel? Well, transversal is this one, AB. Here are the intersected lines. Notice that this line over here is not even touching those two angles. And so the intersected lines here are the parallel ones. DA parallel to CD. Okay, so note that here there wasn't like letter J, lowercase, naming it line J. But there's other ways to name lines with 2 points. So AD and CD. So don't forget that. So then you say the reason, converse of, it says state the theorem, converse of, and then that theorem, same side, interior angles. Make sure you write the theorem. One more I was going to do here, 2 and 3, right here. Those are same side interior, but we don't want them to be congruent. So no conclusion. They gotta match up. So same side interior need to be supplementary, corresponding alternate interior, alternate exterior need to be congruent. on from those, how about, I'd like to make sure to do 15 for sure, and then these proofs. So, yeah, why don't I just, I might need to skip over 14 for now, come back to it if we can. 15, let's do that one for sure. Find the equation of a perpendicular bisector. So there's three parts to this. Perpendicular is 1, bisect 2, equation is 3. So I always just do the perpendicular first. So here's 2 points. 2, -4, -4, it's like this. And they want us to find the line that goes through, that makes right angles and is also bisecting. So it makes congruent segments. So first I find the slope here. I like to do the slope formula. Again, got into the formula. It's in like half the question so far. 8 minus -4 and -4 minus 2. And so that becomes +4, so it's 12 over -6, which is -2. So perpendicular, our slope is going to be 1/2. Alright, don't forget to flip that. So I said slope, I flipped it to make it perpendicular. Second step is bisect. So this point right there, that where our line will go through, is the midpoint. And so that's what I got to do here. You could do it graphically, or we've seen it on like every test, right? Since the past 2 tests at least. The geometry, the summer assignment test, and then unit 1. So please know this formula as well, or you can do it graphically. Right, midpoint is just an average. So you sum the x's, divide by 2, and then you sum the y's and divide by 2. So the x's are 2. So again, not minus here. The slope formula is minus. This one's plus. 2 plus -4. Then the y's are -4 plus 2. So this is, again, plus. It could be plus and negative. That's fine, but it's plus, not minus. So 2 plus -4, it's -2 over 2, which is -1. And then -4 plus 8 is 4 over 2, which is 2. So I'm trying to squeeze it in here. So there's my point, here's my slope. Why don't I, to do the equation, I'll do slope intercept on this one. So this is step 3. All right, it says find the actual equation. And you have a point, you have your slope. So in this form, I'll plug in y is 2, m is 1/2, and x is -1. So 1/2 times -1 is -1/2. I'm going to write it as -0.5. 1/2. And then add 0.5 to both sides, so it's 2.5 for my b. So the final equation, y equals my slope, which was 1/2, and then x, and then plus 2.5. Or you could write 5/2, or 2.5. All right, that's an important one. There's 3 steps there. Each one we know how to do. We've done slope, we've done midpoint, we've done an equation. And then you're going to answer before I look at the 3 proofs. Okay, let's do the 3 proofs. I probably have time to quickly go through each one. I think so. Let's do 16. Hey, just to save time, I will not write statements and reasons. And here, I'll write given. This must be a G. There we go. So lines A and B are parallel. So here, let's read the direction. Given the corresponding angles postulate. So they're kind of telling you, okay, you're going to use that one. Prove the alternate exterior angles theorem. So like 2 and 7 are congruent. All right, so from this, because lines are parallel, we can make a conclusion about angles. Okay, now we can't say 1 and 8 or 2 and 7, because that's the theorem we're proving. It says use this one right here, corresponding angles. I'm going to pick one that involves 2 or 7. And so I'll just pick 2. So I could have chosen 7, and it would have been 3 and 7. I chose 2, though, and so it's 2 and 8. I got that wrong. Sorry, 2 and 6. 2 and 6 are corresponding. Sorry about that. We use that postulate right there, corresponding angles. And this is the one we've seen. We had showed the alternate interior angle theorem before. This is the one where now 6 and 7 are vertical. And I really should say, we're trying to show something about 7. So then you say, well, do I know something about 7? Yes, with 6, they are congruent. So 6 and 7 are congruent. You can just say vertical angles theorem. Also, remember, you're welcome to reference all of these over here. All of the words, here's vertical angles theorem, here's all the angle pairs. Okay, and then similar to the quadrilateral proof number 4, transitive. 2 congruent to 7 by transitive. Anything else I can answer on page 3? Yeah.
Last one answers the same thing.
Okay, yeah, you could have done 3 and 7 are corresponding, 2 and 3 are vertical, and then 2 and 7 transitive. Yeah. So that's just if you would have picked 3 and 7 instead of 2 and 6. Nice. Last page. Let's go there. Okay. Oops. Let's do 17, and I hope we can set up some of the 18. Remember, the answers are at the bottom there, so you can see it, but it'd be better if we could just talk through some of it. I know just for writing, I'm going to need a little more room writing on the smartboard, so I'm going to start right there. Statements, reasons, and then given. So this is what we did in class. Yeah, we had done this one. You're trying to prove C is perpendicular to B, and so you need to get, I think last time I chose 6. You need to get 6 to be a right angle. And we can, but we got to go with what we have up there first. So A is parallel to B. So I'll start like I did on the last one. I think it was 2 and 6. Right, A parallel to B means 2 and 6 are congruent. Corresponding. Let's see if I chose that below. Oh, I did choose 2 and 6. So I'm just going to write over that. So then we'll use my other given. C is perpendicular to A. That perpendicular means intersects to form right angles. So I can choose any of 1, 2, 3, and 4 as right angles. I can write all of them. The only one I really need though is 2. So I'll put angle 2 as a right angle. That was just a vocab word, perpendicular. Definition of perpendicular. Okay, and then if you remember on this one, this was the one we did in class where there wasn't an easy just plug in. Even though you'd like to just plug in 6 right there for 2, there's no property or theorem that says that. So you just change each of these in steps 2 and 3 to an equation, and then you can substitute. So step 2 to an equation becomes measure of angle 2 equals measure of angle 6. That's the definition of congruent angles. And then step 3 to an equation is measure of angle 2 equals 90. vocab word, right angle. So it's definition of right angle. And now with 4 and 5, we can plug in, well, 90 here or measure of angle 6 here. So I'll just plug measure of angle 6 in here. So measure of angle 6 equals. That was just substitution. Transitive would work as well on this one. And let's see, yeah, I want to make sure I hit the last one real quick. But to finish up, let's see, 6 is now 90. So now if it's 90, then angle 6 is a right angle. Definition of right angle. Okay, if it's 90, that is what it means to be a right angle. And finally, if angle 6 is a right angle, then yes, these two lines here, C and B, are perpendicular. C perpendicular to B. Shift lines over them. Definition of perpendicular. There's one other we did like this, where I just want to remind you of, we did all right angles congruent, where we immediately said, because we had two perpendicular, we said they were right angles. We could have changed them both to 90 like we did here, but instead we just used that property. All right angles are congruent. Any thoughts on 17? Okay. I don't know if I have time to write down all of 18. Let's just look at the bottom at, I'll draw it out here. Maybe. It's Mr. Hunt. Hi. Okay. Thanks. Bye. Abby, you're signing up. Okay. Hey, so on 18, given the corresponding angles postulate, prove 3 and 5 are supplemented. This is the same side interior angles theorem. So I said because A and B were parallel, you could make a conclusion about angles. And so I said 1 and 5 are congruent. Corresponding angles postulate. I don't know what I wrote here. And then I wanted to say something about 3 and 5. And 3 was right here. I knew 1 and 3 were supplementary. So I could then say 1 and 3, given in the diagram or linear pair, change that to an equation. Change 1 congruent to 5 to an equation. It's similar to the last one now. Then I plug 5 in there. Definition of supplementary. All right. Yeah, we're basically done. Sorry, I had to wrap up quickly there. Let's see. So tomorrow.